we go. Okay, so why am I here? Why would I bother talking about static typing and dynamic languages? I work here at Planning Center. I write Ruby and JavaScript all day long. Neither of those languages have static types. Everything is runtime. Everything could be wrong. Everything could fall apart. You can't really be sure, or maybe you can. But why I'm here talking about static typing because I spent pretty much the whole year of 2014 working at a C# shop. And I liked it. I kind of started programming in Ruby. Ruby was my first programming language. I had no concept of like declaring a type for a variable. I had no concept of like pointers. I had no concept of these lower level programming things that you would learn if you went to school. I didn't go to school. I got dropped into C# job. I was blown away by the type system. I thought it was weird. I thought it was verbose. I thought it was ugly. And then maybe Stockholm Syndrome, maybe not. I started to love it and feel like, wow, this actually makes me feel really good because I actually know what everything is. Another reason I'm here is because I really like Visual Studio. I spend all of my time in Vim. I spend all of my time in a command line. I really like Vim. I really like modal editing. But I really miss some of the things from Visual Studio. I miss the reality that my editor knew everything about what I was writing and could actually help me fill in the blanks. Like I didn't have a separate window full of Ruby documentation open. I just sort of typed things out and I got function signatures and I got all the argument types. And it was awesome. So maybe by like a show of hands, how many people in this room are writing like either Ruby or JavaScript or some other dynamic language every day? Okay, so most of us. So it's like maybe applicable. So the sort of overarching thing that I want to talk about as far as statically typed languages and dynamic languages, this is like a really broad generalization, but one of the main differences comes up in how we think about applications being correct. When we don't have a type system to ensure that the functions that we're calling, the methods that we're calling, the actions that we're running all have the appropriate types as they get passed in, our only real hope is testing, right? So we write lots and lots of unit tests to try and cover our butts and make sure that things are going to work exactly as we expect them in real life. When you work in a statically typed language that has a compiler step, one of the biggest advantages that you get is you actually have a compiler, and it will do static analysis on your code. So it won't actually run the code like a test, but it will sort of loop through everything and check and make sure, like, you can't multiply a string by a number, right? You can't write, my name times 6. In Ruby you can, but we'll pretend you can't. JavaScript you can't. And in a statically typed language, you'd blow up before you ever had a chance to run your code. That would never pass, it would never fly. You just get an error and it would say, hey, like you can't multiply a string, it doesn't make sense, fix it, and you get a nice error right away. In Ruby, if you were to do something akin to that, where you tried to use a method that didn't exist, if you didn't have a syntax error, you're not going to get any kind of error until you actually hit that part of the program and the whole thing blows up and says, something doesn't have this method, and it's over. So you have this switch about how you tend to think about what's correct. One of the challenges, and there's a really good talk on sort of like application correctness, a guy named Gary Bernhardt, he talked at RubyConf 2015 a few months ago, and he explained one of the challenges is that relying on a compiler to make sure that your program is correct can get you as far as making sure that your program will run. Like you know that everything's going to run, you know that all your function calls are not going to throw errors because you had something that was wrong, but it might not do what you actually think it's supposed to do. And so you actually do need a set of tests to ensure that behavior is correct. Another problem is that if you're in a dynamic language where you already are having to write tests to check that your behavior is correct, you can't guarantee that if your test coverage isn't a full 100%, you don't have any sort of guarantees that some part of your application is going to call a function with a bad type and your whole thing is going to blow up and give you one of those like nice no method errors. So my idea is, like, is there a way to ask them both? Like, could we somehow ask a compiler before we run our code, like, is everything okay? Did I write it okay? Is my application calling things appropriately? Am I screwing something up before the code even runs? And then ask the test suite and say, okay, is my code actually doing what I expect it to? So there are 4 projects that I want to throw out. One of them is called contracts.ruby. One of them is called Crystal. One is called Babel typecheck, and the other is called TypeScript. The first 2 are Ruby related, and the second 2 are JavaScript related. I kind of just want to give an overview of these projects and throw out, hey, maybe you guys will find these useful. So let's talk about Ruby. Let's talk about contracts.ruby. It's basically, you get runtime type checking in Ruby. So what this means is that you can add type annotations to your methods, and when the code runs, if you have the wrong type, you get a nice error. You get like a genuinely nice error that actually tells you why something was wrong. You won't get like a nil error where you won't get an error that says like something doesn't have this method. So here's an example of some code that looks really small. I can make it a little bigger. So here is a class that we use. We call it a DateRange. It's a subclass of Ruby's built-in range class. So Ruby's built-in range class, you give it 2 numbers, and you can do operations on that range. You can iterate through a range of numbers. And a date range, for us, you give it a start date and an end date, and you can query based on a date range. You can check like that certain dates fall inside of a date range. So this is an example of a DateRange class that has contracts included. You see we've got require contracts here. That's the name of the library. We include contracts core. And so this is the method contract right here. So this says, for the initialize method, when you'd call DateRange.new, your first argument should be a date. Your second argument should be a date. We're ignoring the third one. The third one should be a Boolean, and then this is how you define your return. An initialize method in Ruby returns nil. So basically you set this and say, I expect this method every time it's called to receive 2 dates and a Boolean, and I expect it to return nil. And if any of those things, if this method gets called and any of those things don't happen, you get a nice error. So this is a little IRB prompt. We'll require contracts.rb. And then we'll try to create a range. If I try to create a date range with the numbers 1 and 3, I get this really nice param contract error. And it tells me that there was a contract violation, argument 1 of 2, expected a date, and I actually got 1. It shows me exactly where my method was, and it tells me what the contract was, and again, it tells me the actual line number that it was expected to show up at. This can be awesome. There are moments when something like this can actually help you get, it can change the way that you think about whether or not your methods are correct. It allows you to offload some of that thinking to simple type checking and feel good about, sleep well at night. Here's just another example. If you try to do a time and a date, you'll get a contract violation for argument 1 because it expected a date and it actually got a time. Value is guarded with contract. Here's another example. This is an example of a service object. So this is sort of like a dumbed down version of something I actually wrote. You call it with an object, and it generates a zip file full of PDFs. So we're missing the generate method here. But this is actually kind of how it looks in real life. We have a self.call, so you call generate zip export.call with a user. And the first thing it does, it says ensure can export. And that, all it does is it basically throws an error if the user isn't persisted. We're using Active Record, and so any database-backed model is going to have this persisted method that will tell us if it's actually saved to the database. So if you tried to call this right now, if you tried to call this with a user that wasn't saved into the database, it was just been created in memory, you'd get a nice error, this nice cannot generate error. It's really helpful. It works. It does its job. If we throw contracts in here, everything gets a lot shorter and clearer about exactly what we need it to be. So this would be an example of a contract for the same method. So our contract is, we're using and here. So our requirements are that it is a child of active record or a subclass of active record base. And there's this neato send, which basically calls that method on it. And if it returns true, everything's okay. But if it returns false, it will give us one of those nice contracts errors and say, hey, you can't do this because your thing isn't persisted, and I expected it to be persisted. And then all we have to do here is self.call, and that should have been generate, but that code sample is wrong. So, so this is like, we have some boilerplate here. We have like an error that we had to write ourselves. And we get the same thing with contracts in a lot less lines and a clearer syntax around it. I like it. It's awesome. Could totally save your butt sometime. One of the cool things about using it in a situation like this is that it can actually allow you to use, you can write, there are situations where you might be able to write like a smoke test rather than a full unit test on like a controller or something that calls this service. You could just call a smoke test, just sort of run it. If it doesn't throw an error, you're okay, because you know that you actually called your service with a child of active record base that got persisted. For example, if your controller code was in charge of saving a user and then passing it into this service, all you'd really need is a smoke test. You just run the method. If it doesn't throw an error, it worked. Could save you some time testing, gives you a lot of clarity about that. So it's awesome. That's contracts Ruby. It's a little slow. As you might have guessed, it takes advantage of some metaprogramming concepts to like basically redefine those methods. But it's not too slow. All these slides are on GitHub, and that's a link to an article by the author of Contracts Ruby talking about how he sped up the project, and he talks about benchmarks. And effectively, it's not actually that slow. It's cool. And the other nice thing about it is that the author recognized that this was something that might slow people down and might not be great. So it can be disabled in production with an environment variable. You set one thing, and then all those contracts basically turn into no ops. It doesn't mess with your code at all. Everything runs properly. So you write some contracts, you test them. As long as nothing is breaking in development, you know that your contracts are being called correctly. You push it to production. They turn off. You have no performance hits, and you sleep well at night. Next thing I want to talk about, Crystal. Crystal is a language that was developed by Ruby guys who really liked Ruby but felt like it was slow and did not like the fact that it had a weak type system. And so they built this language called Crystal. It's at crystallang.org. This is what it looks like. This is Hello World in Crystal. Man, that's really small. This is Hello World in Crystal. It looks exactly like Ruby. This is some more Crystal. It's also valid Ruby. It's Fibonacci sequence. I don't really have anything else more to say about Crystal. If you feel like you like Ruby, but you are missing, if it's too slow for you, or if you want a strong type system and a compiler step, check out Crystal. Look into it and see it might be exactly what you're looking for. So basically, if I were to run this in Ruby, I'd have no type safety, no type assurance about it. It would work because it's valid code and it would be fine. If I were to run this in Crystal, it would actually know all the types of everything in there. It would be dramatically faster, and I could get errors if I tried to do things with the wrong types. Crystal's great. Check it out. It's cool. Okay, so let's talk about JavaScript now. Actually, Babel. How many people in the room are using Babel with their JavaScript to transpile things every day? Okay, also like a decent chunk. So Babel is a transpiling engine for JavaScript. It's similar. It was sort of another take on Google's Clojure compiler. It takes future proposed syntax for JavaScript. You run it through, and it exports JavaScript that can be run in browsers today. It's a great project. It allows us to do lots of cool things and nicer syntax. I like it a lot. Lots of people like it a lot. Lots of people are using it a lot. I look at it kind of as an industry standard right now. So the first thing I want to throw out is this thing called the Babel type check plugin. So this is something that is trivial to throw in if you're already using Babel. You download this plugin from NPM, and you throw it in your Babel RC when you're in development. This, again, is probably another thing that you would want to turn off in production. But it does something very similar. This is pretty much analogous to the Contracts Ruby project that I showed you a minute ago. This code sample that you're looking at right here is a code sample right from the GitHub repository about what it does. Basically, this is a regular JavaScript function, but you throw on type annotations by colon and following something. So you're saying right here that you have this function called send message. The first argument, called to, has to be a user. The second argument, called message, has to be a string. And the function has to return a Boolean. And if any of those things don't happen, again, you'll get a really nice error that says, hey, like you messed up your contract, you screwed up, maybe you're a bad person. I hope not, but you might have been. It'll save your butt sometimes. I've actually used this one in a number of projects. It really, really annoyed me because I turned it on, I started annotating some of my functions, and I got a ton of errors about things that were about contracts that I was breaking, about times that I was calling functions with the wrong signature. And like anything that is correct and difficult to deal with, my first reaction was, this is wrong, this is stupid, let's get rid of it. Unfortunately, it was correct, and I had a bunch of JavaScript code that was calling functions with the wrong object types, and it wasn't throwing any errors. It's one of the scariest things about JavaScript. It's one of the things that I hear most people complain most about JavaScript is this general sense that it's kind of like the Wild West, and there are a lot of things that can happen that are unpredictable. So something like this gives you a lot of runtime assurance about, hey, what's actually going on here. Again, this is the kind of thing that's really easy. It's very similar to the contracts Ruby that I talked about. Very easy to run in development, write your tests, see if everything's working okay, see if you're throwing some errors, turn it off in production, and it won't slow you down. This is an example, again, of just the kind of code that it spits out. The Ruby project I showed you, Contracts with Ruby, is actually like I said, it uses metaprogramming to redefine those. This is actually a plugin, like it's a Babel plugin that transforms your code from the original set to the bottom set with all the type checks. If you don't like that, if you look into it and for some reason you don't like it, there's another thing called FlowType.js that pretty much does the same thing. And you can look into that too. FlowType.js works as a Webpack loader or a browserify transform rather than a Babel plugin. So you don't have to be using Babel to use FlowType.js. The last thing I want to talk about is TypeScript. There are right now 2 really, really large companies that are going after this idea of typed JavaScript and writing JavaScript full of type annotations so that you know what's going on. They are Facebook and Microsoft. Facebook's project is called Flow. Microsoft's project is called TypeScript. I am at a point where I would really only recommend that people actually use TypeScript. If you look around the internet and you try to look at comparisons with TypeScript and Flow, one of the first things that I ran into was a Reddit post, and it was a group of developers who had done some research on both of them for themselves, and they came away basically with this idea that TypeScript has really, really great developer tools, but you have to go whole hog on it. Like you can't type one thing, you can't add function signatures to one function and call it good. You have to do it to every file in your project or it will not work at all. And they were praising at the time Flow because Flow had this idea, Flow was introduced at Facebook with this concept of gradual typing. You could annotate specific functions in your application and not others, and everything would be fine. You could gradually introduce this idea of typed functions. Oh, that wasn't supposed to come up. So I'm going to show you some actual samples of TypeScript. This is some of the coolest stuff in my mind. This is an application called Visual Studio Code. It is a free editor from Microsoft built on Electron. It runs on Windows, Linux, and OS X, and it brings in a lot of the features. It brings in basically IntelliSense from Visual Studio. Like I said, I liked Visual Studio. I thought it was really cool, and I think that the things I'm about to show you are also really cool. So here is my first example of what it looks like to start writing in TypeScript. So what you're going to see here, this looks exactly like Babel syntax that I might write today. I have jQuery importing at the top, I have a function here. It looks just like the last project where my type annotation is a colon and a type, except you'll notice that I've got a few underlined red things here. So let's look at the first one here. I have a function called uppercase string, and my type here, this colon, is an interface called toUppercaseable. So this interface I've defined right here says that whatever's passed into this method must have a function called toUppercase that returns a string, and it also must have a slice function. That slice function must take a number as the first argument, a number as the second argument, and it must return a string. So what's interesting is I actually have an error here. Even though I'm using, my interface is correct, and I'm calling slice, which returns a string, and then I'm calling toUppercase because I know that strings have the toUppercase method. I'm getting an error because of this line down here on 16, because I'm actually calling uppercase string with a list of numbers. Right here, I'm using uppercase string with a list of strings, and everything's fine because strings fall into this interface of toUppercaseable. They have a toUppercase method and a slice method, or slice function. My list of numbers is not working, and if I mouse over, it will tell me exactly why. It will say, this interface that I've defined is not assignable because numbers don't have the slice method that needs to be called on it, or the toUppercase method that needs to be called on it. So this is nice. Like this will tell me before I've had a chance to run my code. Like this is totally valid JavaScript. This would get to your browser, and then it would blow up then, and you'd get a much more cryptic error about why you can't call slice on a number. Right, and that's what would actually happen. But this is really cool. In Visual Studio Code, I actually get an error beforehand when I'm dealing with TypeScript, and it just says, hey, like you can't do this. So if I were to change this and not call slice anymore, I still have this error because I don't have a toUppercase method. If I change these to strings, my error goes away because everything has all the functions it's supposed to have. Another thing I want to show you is some of the IntelliSense stuff here. So this is, I'm calling map on a list of numbers, and I hit Control Space. I'm going to get information on what map does. So map, I can see here, takes a callback function, and that callback function, the first argument is the value, and it's a number. The second argument is the index, and it's a number. The third argument is an array that's a number. So this is just a regular old JavaScript map function. You can look it up on Mozilla's got great JavaScript documentation. But it tells you some really helpful things here about what exactly map does. And so when I go in here to create a callback, let's say that my first, I want to use this number, and I'm going to return, number times 2. And I can get over here and see, like, this parameter I know is actually a number because of the callback. If I change this map function to operate on list of strings, and I look again at the definition, at the hints for map, you'll notice that my value has changed to a string. My index is still a number, but my array that comes in at the end is an array full of strings. Really neat stuff. There's a really awesome project out there called Definitely Typed, which allows you to download, because the JavaScript libraries that we know and love and work with every day do not come with type information. You just have to read the docs and figure out what they do. There's a project out there on GitHub called Definitely Typed that allows you to download TypeScript definitions for all the types they come with. So this is a really cool thing. It's a pretty basic jQuery deal here. You're going to make an AJAX call to your post endpoint, and when it finishes, you're going to do something with it. What's awesome is that it actually, where's my hinting? It's gone. This one isn't working anymore. If it was working, if it was importing properly, it would actually be able to tell me everything that I need to know about what this XHR is, what this data is, and what this text status is. Bummer that one stopped working. I wonder if my other ones will stop working too. The basic idea is you get a ton of inline documentation for these JavaScript libraries that you use every day. And it's a pleasant developer experience. I don't know what else to say. It has really great support for React. So this is an example of a React component. I have this person introduction component. It extends from React component, and I'm actually giving it, and I'm telling it this is the shape of my props. I'm using interface again, and I'm saying that my props, so rather than using built-in React prop types, I'm actually using TypeScript's abilities to set an interface and say, you can't use this component unless you give it a name. And then this one with the question mark says you can, the age prop is optional. And you'll notice down here when I try to use this component, I get an error because it says property name is missing in type person introduction props. This is really cool. If you use React prop types, you know that you'll get runtime errors, but you will not get editor errors or compile time errors. You can get it with Visual Studio Code and TypeScript. One last thing that's just, so this is like an example. Maybe you are going to create a post. You're going to post to your server with something. We have, man, this worked better when I could show all the code. And basically, like, what's cool is that if I define I have an interface here, this interface post, and it says it might have a UUID, it definitely has to have a title, and it definitely has to have a body. And if I add that as the interface for my create post function, I'll start to get errors down here. And it'll tell me when I tried to use my create post function, this post that I'm using right here, I can't use it because it only has a title, and so it doesn't match with the definition of the interface. If I get in here and give it a body, everything's okay because it now matches the interface that I defined. Same deal here with this build post function. It knows what the return type of this function is, even though it knows that build post returns nothing right now because I forgot to put a return, and so it's giving me nothing. If I actually were to go in here and return, this will turn okay because now my build post actually works. There's some other examples here, but I think I'm running short on time, and so I'm going to skip them. Basically, that's some TypeScript examples for you. It's available today for $1.99. No, I'm just kidding. It's actually available probably for free. The cool thing about every example that I just showed you in the type check example and the TypeScript examples is that those were all 100% valid Babel code. If you're using Babel, you don't have to do anything at all. You can write all of that. You can write it in Visual Studio Code. You can get all this cool type hinting. You can get IntelliSense. You can get all these compiler errors. And you don't have to change anything about your config files. This would work in any of your projects that you're using Babel on. So I'd recommend you give it a try. The only major gotcha with TypeScript right now is that you have to use a .ts extension. You can't use .js, but it is trivial to start using it in Webpack, Browserify. We use it in Rails. It's awesome. So I'm pretty much done. That's pretty much all I have to say. I think that these are really cool projects. I think they give us opportunities as flounderers in the land of dynamic languages to be more correct, have more confidence about our code, and write large applications that we can trust. I'm Daniel Ma. All the code for this whole thing is available on my GitHub at /talks. It'll be there after I push it in 5 minutes. Thanks.